That? Is that what you're? Yeah. Okay, so this right here is the same distance angle-wise as that, right? Yeah. So what would this angle be going from here to here? It would be 180 plus 36.9. Plus 36.9. Because you're looking at this right here is like an absolute value almost. It's how much you're adding, right? To the 180, it's how much you have to add to get here. The reason why it's negative here is because we went this way to get to it. Okay. You sure? Yep. Okay. It's a good question. It's confusing because it's negative here, but that's only because the rotation was this way. In terms of an absolute value, just take that angle and just move it around in space. That's like 36.9 degrees, right? So if I want to take that and put it here, then I'm going to take the 180 and add to it. I think this will become more clear as we do more problems, because we're going to have to do this today. Not in every problem, but in a lot of them. All right, so our whole goal here is to solve trigonometric equations, right? Solve trig equations. So I'm going to put two problems on the board that I want you to look at, and I want you to tell me what the difference between these two problems are. So for this one, I want you to solve this, right? I want you to solve cosine of theta equals 1/2 versus cosine inverse of 1/2. This is a trig equation, okay? You have an equal sign here. You have an equation. It's a trig equation because it involves a trigonometric expression and then a theta, a variable in here, right? So I want to know at what angles, right? This is saying at what angles on the unit circle is the x-coordinate 1/2. You know where that happens? The x-coordinate is 1/2. That happens here, right? Y'all agree that that's pi over 3? Is that the only place? Is it? No. Pi over 3? Right here, negative pi over 3. Or you could say 5 pi over 3. It's up to you. So how many answers do we have here? Over here. 2, yes. Just 2? Remember the last test? There's an infinite number of answers because we could go to pi over 3, right? We could go to this angle, pi over 3. But then couldn't we have gone all the way back around to pi over 3 again? Like all the way around? So remember what these answers looked like?
Pi over 3 plus k.
The theta is pi over 3 plus you got to go all the way around back to it, right? So what?
K.
Not just k, 2 pi k. Remember the 2 pi is what gives us the full rotation. And the k is how many rotations we have. Does this represent all the answers? Yes. No. That just gave us this one, right? We need this one as well down here. So you can get to this point. What do y'all want to do? Do y'all want to go around, go to 5 pi over 3, or you want to go backwards and go negative pi over 3? You want to go negative pi? I heard negative pi. Negative pi over 3, right? So this would be theta is negative pi over 3 plus 2 pi k again, because you have to go all the way around to get to another answer. So for this trigonometric equation, you have 2 sets of infinite numbers of solutions, right? 2 sets of these. Yeah? This problem isn't, the way we were doing this problem, weren't we saying just a second ago, this is some angle theta, so that cosine of theta equals what? 1/2, right? Isn't that what this, that's how we interpret this. Cosine inverse of 1/2 is asking for some angle that when we take cosine of it, we get the 1/2. Isn't that the same equation? But is it the same answers? No, why not? The domain restriction. This domain restriction says I can only have answers between 0 and pi for cosine inverse, which means my only answer, it's the same picture, you see, but you're now going to cut the bottom of this off, right? You're not allowed to look down here, only look 0 to here. Now there's only one answer. The answer is unique. It is pi over 3. So here your answer is pi over 3, which means that this is pi over 3. Do y'all see the difference between these two problems? There's a huge difference, right? For this problem, you cannot just go to your calculator and type in cosine inverse of a half and get an answer of 60 degrees and be done. You have to understand the geometry of this. So today our focus is this, all right? This right here. Which is kind of good because we don't have a domain restriction, kind of. All right, let's do another one. Why is that blue? Solve cosine of 2 theta equals a half. Pay attention. Is that the problem we just had or no? Is it? What's different? I got it. Yeah, there's a 2 inside next to the theta instead of just theta. Yep. Right? Y'all see that 2 right here? Right there? So this is still asking us the same question. The way that I look at this is this. This in here is just some angle, right? That's just some angle. Cosine of some angle has to be a half. So to me, I'm still saying to myself, okay, where on the unit circle am I going to have an x-coordinate of a half? Well, that's still here and here, right? So what I need is for that angle to either be there or there, right? But it's 2 theta now, not theta, it's 2 theta. So I'm going to write this. 2 theta must be pi over 3 plus 2 pi k, or 2 pi over 3, 2 theta must be negative pi over 3 plus 2 pi k. Y'all recognize this as being the answers that we just got in the previous problem? Those are the 2 answers, right? The only difference is I'm not saying theta has to be equal to that. I'm saying 2 theta has to be equal to that. What do we call the thing that's inside the trig function? What do we call that thing again? The argument, right? So what I'm doing is I'm setting the argument equal to the 2 general solutions I get off my picture. I don't need to go through this work again, right? Pi, add 2 pi k, negative pi, add 2 pi k, right? So that's the slight little difference between this problem and the previous one. I'm not done. I need to solve for theta. So how would you get theta by itself here? Divide everything by 2. So this becomes theta equals pi over 6 plus, divide that by 2, you get pi k. Over here, you get theta equals negative pi over 6, and then plus over here pi k. These are your 2 answers. Any questions there? Yes? Plus or minus pi over 6. Oh, yeah, well, I guess for this one you could. If you wanted to, you could put plus or minus. But I don't think it's going to happen that often, so this would be kind of a unique situation. We good? No questions? Okay, so how would this change? What if I change this now to 1, let's go with 1/4 pi, or 1/4 theta, sorry. 1/4 theta. So this is a new problem now, right? Excuse me? Divide by 1/4. I'm going to do something, I'm going to multiply by 4 instead of dividing. But it's the same picture, isn't it? It's the same picture, except instead of saying 2 theta, I'm going to say 1/2 or 1/4 theta. Right, that'll change this answer. And then over here, change that to 1/4 theta, and that's going to change this, right? Am I going too fast? Do you all see what I've done? Same thing, cosine of 1/4 theta is still a half. It's still these two important angles. I need all the answers, right? So I say pi over 3 plus 2 pi k, negative pi over 3 plus 2 pi k, but it's the argument's different, right? The argument's being, the thing we're setting it equal to is different. So I need theta by itself. You can divide by 1/4, but I think it's better if you just multiply everything by 4. So if I multiply this by 4, I get 4 pi over 3 plus 8 pi k. Or theta is negative 4 pi over 3 plus 8 pi k. Those are my answers now. Any questions? Come on. Let me give you another one. Let's go back to this one right here. I'm going to put the 2 theta back in there, right? I'm going to put the 2 theta back in there. Let me get rid of all this shit. Okay. So I want you to solve this, okay? But I'm going to throw one more thing on here for you. On the interval 0 to 2 pi. So what I'm telling you now is that I would like for you to give me all the values of theta that make this true, but I only want answers between 0 and 2 pi. So we did this problem earlier, right? We just did this a second ago. And we didn't have this here, right? And what were our answers when we had just this without that? We had those general solutions, right? What were they? I don't want to go through the work again. It was pi over 6 plus pi k, right? Or the other one was theta is negative pi over 6 plus pi k, right? Those are my 2 sets of answers that I had when this was 2 theta a second ago. So I'm going to do the same work that I did before. I get my 2 general solutions, but now I only want answers that are between 0 and 2 pi. So what I need to do now is start letting k take on different values and start spitting out answers. Right? For example, if k is 0, what's the answer here? Is that within here? Is pi over 6 in there? Yes. Right? What if k is 0 here? Negative pi over 6. Is that in there? No, it's negative pi over 6, right? That's not in 0, 2 pi. So that's not an answer. Then I need to let k be 1 and then see if those answers live in there. Then let k be 2 and see if those answers live in there. You see what I've got to do now? It's kind of a pain in the ass. Yeah? We just have to just plug in values of k. Now, because we have to plug in values of k, I think personally it's easier before you start plugging in values of k to get a common denominator between these two. This is an optional step, but I highly recommend it. I'm going to do this. Rewrite this as pi over 6 plus 6 pi k over 6. See, I'm getting a common denominator between these, so I multiply top and bottom here by 6. This is like over 1. And then on the top, you put pi plus 6 pi k. By the way, that is not 7 pi, because this is pi, this is 6 pi, the k is attached to the 6 pi. You cannot put the pi and the 6 pi together, right? You can't do that. You have to multiply before you add. So you just leave those just like that, and then over 6. Do the same thing over here. Negative pi over 6 plus 6 pi k over 6. Get your common denominator. Negative pi plus 6 pi k over 6. This is not my answer. I'm just boxing those to let you know that that's what I'm going to work with. All right? So I want all the solutions to this, but only answers between 0 and 2 pi. I found my general solutions, and now what I've done is I've got common denominators. This should make it easy for me to plug in k. Where do y'all want to start? K is 0, right? Let's start with k is 0. If k is 0, what are the two answers I get for theta? Because I have two boxes to work with, right? Two of these. So if k is 0, that's gone. You just get what? Pi over 6. And then over here, if k is 0, you get negative pi over 6. So we have pi over 6. And over here, negative pi over 6. And I'm throwing that one out because it's a negative answer and it's not in this interval. Now I let k be 1. If k is 1, I get what and what. So if I plug in 1, do y'all see why I got a common denominator? Do y'all see why I did that yet? If I plug in 1 here, what do I get? How many pi's? 7 pi on top over 6. You're done, right? But what if you plug in plug in 1 right here? What are you going to have to do? What's pi over 6 plus pi? You're going to have to put them together, right, and get a common denominator, right? So you're going to have to find a common denominator here anyway. And then when you let k be 2, you're going to have to do it again, common denominator, and then again, over and over. So why don't we just do it one time in general, and then we can just keep using this formula. Right, so k is 1. What did we get there? 7 pi over 6? Is 7 pi over 6 in this interval? How can you tell that that's in there? 7 pi over 6 should be a common angle, right? Yes? It's one of our common angles. Here's another way to think about it. The number in front of pi here is 2, right? If you take 7 and divide it by 6, is that number bigger than 2 or no? It's not as big, right? 7 divided by 6 is like 1 point something. So we're not past 2 pi yet. What if we plugged in 1 into this one? What do we get? Careful. Negative pi plus 6 pi is how many pi's? 5 pi's over 6. Is that in there? Is 5 pi over 6 between 0 and 2 pi? Yeah, because 5 divided by 6 is what? I don't know, point something. It's bigger than 0, right? And it's smaller than 2. So that works. What if k is 2? This sucks, doesn't it? The general solutions, I love general solutions because then you don't have to do this step, right? But now if you have an interval, you have to do more work. What if k is 2? 2 here. 2 times 6, 12. 12 pi plus pi? 13 pi over 6. So I get 13 pi over 6. Is that bigger than 2 pi? Yes, because 13 divided by 6 is bigger than 2, right? So you're done here, right? You're done. That means you don't have to do any more k's here because you've exceeded the interval. You've gone past the 2 pi now. So you don't need any more k's here. But we do need to check k is 2 here. So what about k being 2 here? That's 12 pi, right? And then you're taking away a pi. That's 11 pi over 6. Is that in there? Yes. How about k is 3? We don't need to check here, do we? We don't need to check it. We already know the last one was too big, right? So the next one will be too big. How about k is 3 here? 3 and 6 is 18 pi. Take away pi. It's 17 pi over 6. Too big. I'm going to put it here. 17 pi over 6 would be our next one. And this was for k is 3. And that doesn't work. So how many answers do we have? 4 solutions. We have 4 solutions. The 4 solutions to this trig equation are pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. It's fun, yeah? Let's try a different one. Solve this equation. Yes?
So how about 7 pi over 6 and 5 pi over 6? Those are on the left side, and then they say they're equal to 1/2. would that still?
Wait, that would have been if the original equation was cosine 2 theta equals negative a half. Which ones were you talking about?
So
You're talking about.
You're
talking about-
The one that we just did. It was cosine 2 theta is equal to 1/2.
Yes. What about it?
And then we just did all those things. We did 7 pi over 6 and.
Oh, okay. Now I think I know what you're saying. Okay, so what's being brought up? Maximus, right? Well, Maximus is saying, well, wait a minute, hold on. Our answers, right? 7 pi over 6, like 7 pi over 6 on my unit circle, 7 pi over 6 is like over here, right? So what the hell? The cosine of that's not a half. Is that what I'm getting?
Yes.
Well, the thing is, we're not plugging in 7 pi over 6 into cosine. We're doubling that, right? We're taking 7 pi over 6 and putting it right here. So what would happen if we did cosine of 2 times 7 pi over 6? What would we get? You see what I'm saying? This right here is 7 pi over 6. So I still need to double it. So what would happen there? Cosine, let's see, this 2 cancels 1, we get 3 here. This is really 7 pi over 3, right? What's cosine of 7 pi over 3? Well, let's count by pi over 3s. 1 pi over 3, right? 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. We're right here. What's the x-coordinate there? 1/2. Is that answering your question? Yeah, so our answers aren't going to be, like these angles are not where the x-coordinate is a half. These angles are what we need to plug into the equation to get 1/2 to come out after we do whatever happens in here. It's a good question, yeah? You all got that? Let's do another one. How about this? How about tangent of 3 theta plus 1 equals 0. And we're going to do this in 2 parts. Part A, find the general solutions, or general solution. Part B, find solutions in the interval, let's go 0 to 2 pi again. I want to know when tangent of 3 theta plus 1, when that equation equals 0. First, we're going to get the general solutions. Then we're going to use the general solutions to figure out what solutions fall between 0 and 2 pi, which means we'll have to let k be 0, 1, 2, 3, and figure out which answers fall in here. But we need to be able to solve that first. So I'm going to try and get the tangent 3 theta by itself. I'm going to subtract 1 on both sides. That is saying to you, hey, look, tangent of some angle, let's cover up this 3 theta, not worry about it right now. Tangent of some angle is -1. Do you know where we are in the unit circle? When tangent, where is tangent -1?
3 pi over 2, maybe.
Careful.
3 pi over 4.
Tangent is -1 here and here, right across from it. Isn't it? Now that goes back to, again, your understanding of the unit circle. You have to realize that tangent, remember, is the y-coordinate divided by the x-coordinate. When would that ratio be -1? Whenever the x and y coordinates are the same numbers except off by a sign. So that happens over here because that's -√2 over 2, +√2 over 2, and over here it's +√2 over 2, -√2 over 2. So the ratios would be -1. Yeah? Okay, can you give me the general solutions here?
3 pi over 4 plus pi k.
Good. So you're going to start, you want to get to here, right? That angle right there, let's say that angle is 3 pi over 4. But because the other angle is directly across from it, we can, instead of going around by 2 pi k, we can just jump by half rotations, which is pi k, right? So we would say plus pi k. That was on your last test, right? We did something like that. I tried to do these earlier in the semester so that we would be a little bit more comfortable with them now. Any questions on this? We want our angle to be this, right? We want our angle to be this, but what's our angle? It's not theta, it's what? 3 theta, right? We need 3 theta to be equal to this. So I'm going to just from here say, okay, 3 theta must be equal to 3 pi over 4 plus pi k. I'd like to solve for theta. So what should I do to solve for theta? Divide everything by 3. Okay. So theta would be, if you divide that by 3, yes, you would get a 12 on the bottom, but you could also just cancel the 3's, couldn't you? So that would be pi over 4 plus over here pi k. Well, you have to divide by 3. You can't really do much about that, right? Dividing everything by 3. That's a general solution, isn't it? That's the answer to part A. I'm done with part A. But because part B is asking me to find the answers between 0 and 2 pi, I'm going to go ahead and get a common denominator on this right now and put these together. So what's my common denominator if I want to put those together? 12. So I have to multiply 3 on top here and bottom, and then 4 top and bottom there. So theta is, hey, look, if on a test I just ask you for general solutions, you don't need common denominator. You can just leave it like this, and be done. But if I'm asking you for more, you're going to need to get the common denominator. Well, you don't need to. I suggest it, so that you don't have to do it each time you have a different k. So we said multiply top and bottom here by 3. This one top and bottom by 4. Now that they have the same denominator, it's 3 pi plus 4 pi k, all divided by 12. And do not put that, it's not 7 pi k. Right? This is an apple, that's an orange, okay? You can't put the apple and orange together. All right, that's my answer. Yes?
I have a question as to why we didn't do
The negative.
like we did for the cosine. Is it because they were inverse of each other? Or?
Why we didn't do like negative pi over 4 or something like that?
Yeah.
Because these were directly across from one another, I can start here at 3 pi over 4 and I can add a pi k that would take me to the other answer. And then add another pi and it would take me here, another pi here. So I can get to both of them jumping back and forth by just adding half rotations. In the previous problem, because of the geometry of this, these two are not directly across from one another. So you can't jump from one to the other like nicely. So you have to have 2 different answers and then jump all the way around, all the way around, all the way around for that one, and then this one jump all the way around, jump all the way around. Is that clear? Okay. You could have, if you wanted to, you could have done this problem by saying 3 pi over 4 plus 2 pi k, and then you could have done a separate solution, negative pi over 4 plus 2 pi k, and you would have had 2 sets of general solutions. But you're kind of not working efficiently that way because you're making more work for yourself rather than seeing they're directly across from one another. All right, let's start plugging in values of k. I'm gonna erase this right here. So if k is 0, remember we're only looking for answers between 0 and 2 pi. If k is 0, what are our answers? Well, if k is 0, what do we get? 3 pi over 12, but that's really just pi over 4, right? That's one answer. Does that live in the interval 0, 2 pi? Yes, right? So I can keep that one. If k is 1, k is 1. Now it's 7 pi on top, right? If k is 1. Is 7 pi over 12 in that interval? Remember, we're looking between 0 and 2 pi. Well, 7 divided by 12 is smaller than 2. So this is still a good answer. Let's let k be 2. If k is 2, what do we have here? 8k, right? 8k plus 3, I'm sorry, not 8k. 8 pi plus 3 pi is 11 pi, right? Over 12. Does that still live in 0, 2 pi? Yes, because 11 divided by 12 is still smaller than 2. All right, got to keep going. K is 3. If k is 3, 4 times 3 is 12. 12 pi plus 3 pi is 15 pi over 12. Is that still, I guess I could reduce this one, right? 3 goes into that, what, 5? 5 pi over 4, is that still in there? Yep, because 5 divided by 4 is still smaller than 2. Shit, how long are we going to go here? K equals 4. If k is 4, let's see, 4 times 4, 16 plus 3, 19? 19 pi over 4? Oh, no, not over 4, over 12. Is that still smaller than 2 pi? Yes, 19 divided by 12 is still smaller than 2, right? It's not going to be, we're not going to be outside of this until we get to past 24, right? I think it's going to happen on the next one. If k is 5, we have 23 pi over 12. And that is too big. Because 23 divided by 12, oh wait, no, hold on. No, this one's okay. Yeah, this one's okay. 23, oops, I almost threw out an answer. Okay, k is 5, works still. K is 6. Here we're going to bust out of the solutions. So k equals 6. K is 6 times 4 is 24, plus, so we're at 27 pi over 12. Finally, 27 divided by 12 is bigger than 2, so this is finally bigger. There we go. Show of hands here. How many of you feel like you're grasping this? Yeah? Yeah? You're going to need to do one on your own. I'm not ready to give you one yet. Okay, let me work maybe one more of these, and then I'm going to give you one.
How would you write the solution?
These are them. You just box these answers up. Yep, you just box these answers up. If you want, you could write them as a list. If you're doing a test, just do what I'm doing and box your answers. All right, same instructions. How about this?